Hello there, Algebra 1A, and welcome to Lesson 2.5, the distributive property. We're going to start out with some vocabulary here. Basically, equivalent expressions, those are two expressions that have the same value. And where the real money is today, the distributive property. The distributive property takes multiplication and distributes it to parentheses. For example, if we had 5 times 2 plus 6, what we can do is we can use the distributive property to take 5 times 2 and distribute it to plus 5 times 6. Okay, that's what we're doing. We're distributing. It's also more evident with variables. If we take 5 times a variable expression, a plus b, what we come to find is that's the same thing as 5 times a and 5 times b. Okay, this is going to lead to something known as different terms, coefficients, and constants. Terms are parts of an expression separated by plus or minus. For example, when I say expression, that's something like our 5a plus 5b. And let's say minus 6. So that's an expression. Has 3 different terms. This is term number 1, the 5a. We can call that the first term. 5b is another term. Okay, it's a little different. And negative 6 is a term as well. Okay, so all those things. Within those terms, we have different types. One type is known as the coefficient. Coefficient is the number part of a term. The number part of a variable term, I should say. A variable term is going to have a variable with it. So 5a is a variable term. Negative 6t is a variable term. 3x squared we'll see is a variable term. And the constant, or the coefficient, are the numbers out front. So the negative 6, the 5, and the 3 are all coefficients. Constant terms, on the other hand, those are terms without a variable. So they're just simply numbers. So 5, negative 6, and 2, and 0, and 1/2, those are all constants. Like terms, they have the same variable or are both constants, and they have the same exponent. Okay, so we're going to see what that means in some examples below. So like terms. For example, 5a to the third is like, I'll put a smiley face, negative 6a to the third. They're like. They have different coefficients, but that's okay. It is the variable and exponent that makes them the same. So let's check out this distributive property here. The distributive property, let a, b, and c be any real numbers. So basically what we can say is a times a quantity is just like distributing it with multiplication. Distribute is multiplication. A times B plus B times C is what that would look like. For example, 4 times 2 and 4 times 3. You could simplify that and say that's 8 and say that's 12. That's essentially what's going on. You can also do it backwards. You can do A times the quantity backwards. B times A and C times A. For example, going backwards, 2 times 3 or 3 times 2 and 5 times 2. So backwards. It works the same with subtraction. AB minus AC and backwards as well. So that is a general idea. Now when you distribute, what you might see me doing is 7 times 5 is really 35, and times negative 3 is really negative 15. So you might notice something like that going on. 9 times 6 is 54, and 9 times 4, 36. So that is the process of distributing. Going to be very big in what we do next. So to write an equivalent expression or equation, this is where it gets a little more interesting. So again, be sure to distribute the factor outside to all the things in the parentheses. Sometimes students forget. You got to distribute to everything. So example A, 4 times A is 4A. Now, 4 times 3, go ahead and actually do that multiplication. 4 times 3 is 12. That is the equivalent expression and what I mean by that. Backwards, so 6a, we usually write the variable after the coefficient, plus 30. And 3x minus 24. Here is an extra special one. When we distribute x to 4, that's 4x. When we distribute x to x, that is minus x times x, which is actually x squared. So make note, when you distribute the same variable to each other, you actually add those exponents. We'll do more with that, but, so it's a 1 and a 1, it just becomes an x squared. We'll practice some more of that in time, but that's the idea. Okay, distributing a negative. You have to be careful with that because it's going to make a negative number. So negative 3 times 7 plus negative 3 times x is negative 21 minus 3x. Now, for part B, take your time. Negative 2a times 6 and times a. Look at them individually. 6 times negative 2 is negative 12. We still have the a there. What do we have here? We have minus a negative. So negative a times a negative. Negative is positive, and 2a squared. The a squared came from a times a. Also, it's a negative. So negative and negative is positive. So try out the distributive property on some of these here. 5n plus 20. Negative 3a. Negative a times negative is negative a squared, or negative a times positive. Okay? Let's check out a few more ideas here. Identify the terms, like terms, coefficients, and constant terms. Okay? So, what we have here is our first example of combining like terms. First off, let's identify the terms. The terms here are 2x. I'm going to highlight them in different colors. The next term is negative 5. The other term is 8. and negative 3 is also a term. Okay, so I know I have another example here, but those are the terms. Negative 8x I should have here. Coefficients of those terms. So we actually are going to combine our like terms. So like terms, anything that are like, the variables and the coefficients combine. So 2x and 8x can become 10x. 5 and negative 3, they're both constants, so we can combine those, and that would be negative 8. Now, in that expression, the coefficients are 10, and the constant term is negative 8. So I know I went over it a little funky there, but that's what we're looking into. Let me go through another example here, and I'll label it kind of how you should think about it. So first, when you come to a problem, our goal is going to be identify the terms, the coefficients, and the constants. Before we do any of that, we're going to simplify. So we're going to combine the like terms. Anything that has the same variable can add together. So the a's, I could take negative 6a plus 3a, and that's going to give me negative 3a. The other things that can combine are the constants, 10 and negative 4. 10 plus negative 4 is plus 6. From this expression, then check out what terms we have. So we have a term of negative 3a, and we have a coefficient of negative 3 then, and a constant of 6. Okay, so for 4 here, start by combining like terms. We'll add our y's together. Negative 11 minus 1, we'll also combine those. We're going to have our terms. Our coefficients, and our constant. Okay, so that's that in a nutshell. Homework for this one, 2.5. The odds will do as well. And good luck. I believe in you.